In this video, we're going to talk about proving triangles congruent, and we're actually going to write proofs that prove triangles congruent in this video. So a couple of things to remember before we get started with our proofs. If you are proving that two triangles are congruent, it's going to come down to one of our five methods: SSS, SAS, ASA, AAS, or HL. Remember, HL is only for right triangles. Keep in mind, just because you have a right triangle doesn't automatically mean that they're going to be congruent by HL. It just means that when you have right triangles, it's a possibility that you can use HL. So don't just jump to HL. Definitely make sure that you have the information that you need, which would be congruent hypotenuse and a congruent pair of legs. Here we have our first proof. I highly recommend that you pause the video, you take a look at the givens, and you try to mark whatever conclusions that you can in the diagram. You can take a piece of paper and you can draw the diagram on a piece of paper. TP is the perpendicular bisector of RS. Perpendicular bisector is a two-part word. Let's start with the perpendicular part of the word. Since TP is perpendicular to RS, that means it's forming 90-degree angles because perpendicular lines form right angles. And since these are both right angles in the two triangles, TRP and TSP, we know that they are congruent angles because all right angles are congruent to each other. They all have the same measurement of 90 degrees. TP also is bisecting RS, and that means that it's splitting segment RS into two congruent parts. So not only do we have the congruent angles from our right angles, we now have a congruent pair of sides. I see a shared side between the two triangles. We really like when we have a shared side, and by that I mean a side that's the same in this triangle and this triangle. TP is a side of triangle TRP, and it's also a side of triangle TSP. So it's shared between the two triangles. It's where they're touching at. When we have a shared side, we really like it because we know that it is congruent to itself. TP has to be the same as TP, and that's reflexive property. So now we have enough information to prove the triangle's congruent. As you can see, we have side, angle, side, side, angle, side. So we're going to be proving the triangle's congruent by SAS. Now that we have our plan of how we're going to achieve our goal and the information that we're going to use, all we have to do is write this up in a two-column statement reason chart proof. And sorry for my messy handwriting on the computer. I'm trying to write fast. Okay, so first we're going to start off with our givens. So TP is the perpendicular bisector of RS, and that is definitely given to us. From there, I'm going to put the conclusions that we drew from knowing that we have a perpendicular bisector. The first conclusion that we drew was that, oops, the first conclusion that we drew is that these angles are both right angles. Angle TPR and angle TPS are right angles. And we knew that because perpendicular lines form right angles. After that, we were able to say that angle TPR and angle TPS are congruent to each other because they're both right angles, and all right angles are congruent. After that, we said that RP was congruent to SP, and that was because we knew that RS was being bisected. So I'm going to put that here. A bisector splits a line segment into congruent parts. Finally, our last piece of information was our shared side TP. We know that TP is congruent to itself by the reflexive property. And now we have enough information to achieve our goal. Triangle TRP is congruent to triangle TSP, and that is due to SAS. Let's double check all the information we needed for SAS ended up in our proof. So we have our congruent angles. That was our A right here in step 3. We had RP and SP. That was a pair of sides. And we have our shared side. Now, I know in the proof, I didn't put it in the order of SAS. It's all good. As long as in the diagram, it is in the order of SAS, that the A is in between the two S's. And here I have SAS, SAS. The reason it's not in order of SAS in the proof is just because I went in the order of the conclusions that I drew from the given information. But if it's less confusing for you to order it with the side, the angle, and the side, you can definitely write your proof up that way. The order does not matter of your statements and reasons, as long as whatever is necessary for proving the triangle's congruent comes before you actually say they're congruent to each other. Moving on to this next example, I recommend that you pause the video, draw the diagram, and try to mark the conclusions that you can draw from the givens in the diagram. Here we have that MJ is perpendicular to JK and that ML is perpendicular to KL. Perpendicular lines form right angles where they intersect. So I know where MJ and JK intersect, they're going to form a right angle. And where ML and KL intersect, they're also going to form a right angle with each other. And look, a congruent angle if I need it. We also know from our givens that JK is congruent to ML. And I also see a shared side, like we had in the last example. Side MK is a part of both of the triangles, so we can say it's congruent to itself by the reflexive property. So we have a bunch of information, and I've used all of my givens. So let's take a look and see which one of our 5 methods applies, if any. So here I see, if I start with the green side and go around each of the triangles, side, side, angle, side, side, angle. If I read it backwards, ASS, angle side side. Remember, SSA backwards is a bad word that you don't want to be putting on your geometry test or on any of your proofs. And it's actually not a valid method for proving triangles congruent. Whether you call it SSA or ASS, it is the same thing and it does not work. So that's not going to happen. It's also not SAS. You might think it is because the angle is not directly in between the two sides. If this was going to be SAS, the other side would have to be here, making it side, angle, side. But here we have side, angle, jump side. There's a missing piece of information. This is not side, angle, side. This is ASS or SSA. But then I remember we have a special method for proving triangles congruent that only works with right triangles, and that's HL. Maybe that's going to work here. I do have 2 right triangles, but let's check that we also have the H part and the L part. For the H part, we need to have congruent hypotenuses. The hypotenuses are across from the 90-degree angle. And if I look across from the 90-degree angle, that's side MK in both of the triangles. And we do know that that's congruent to itself by the reflexive property. So the H part is all good. Now let's check the L part. The L part is a congruent pair of legs. In a right triangle, the other 2 sides that are not the hypotenuse are called the legs. So JK and ML are a pair of legs. It doesn't matter if you had these legs or if you had these legs. As long as you have one pair of legs, that is good to go for HL. So we do have the right triangles, congruent hypotenuse, and the congruent leg. So HL is the way that we are going to go. So now all we have to do is write up our statement reason chart. We have all of our information. Let's get that into our. So for our givens, let me just write those, really, really quickly. Of course, I make mistakes when I'm writing, when I try to write really, really quickly. Okay, there's our givens. Now I'm going to start off with the conclusions I drew from the givens. So I drew the conclusion that angle MJK and angle KLM are right angles. And we knew that because perpendicular lines form right angles. So now that we know that we have right angles in each of the triangles, we can definitely say triangle JMK and triangle LKM are right triangles. And we know that that's necessary to say because we are going to be using HL to prove the triangle's congruent, and HL only works when we have right triangles. So that's why it's super important to come up with your plan before you start writing your proof. Otherwise, you might not realize that certain things should be in your proof. A triangle with a right angle is a right triangle. Okay, let me continue over here to put in the rest of the proof. There's not much more to go. Now I'm going to put that MK is congruent to itself, and that is the reflexive property. And now we have enough information to achieve our goal. Triangle JMK is congruent to triangle LKM, and that is due to HL. Let's just make sure that we have everything we need in the proof that we marked in the diagram for HL. So we do have the right triangles. That's right here in step 3. I'll just put a little star next to it because we do have that. The congruent hypothesis, that's MK congruent to MK. So I'm going to write that here. We have our H. And then our congruent pair of legs, that was JK and ML. And we didn't have that here from the givens. So we do have our right triangles stated, our H and our L. So we are good to go for HL. For the next couple of proofs, just so that this doesn't take all day in this video, we're going to mark the diagram together and talk about the plan, and then I'm going to show you the proof completely written up. I do recommend that in between us marking the diagram and talking about the plan and me showing the written up proof that you do pause the video to try to write the proof on your own at this point. Okay, so here we have RO congruent to HE. So here's RO in red, and here's HE in blue. We have angle THL congruent to angle MER. And we know that TO, oops, wrong one, that TO is parallel to MR. So let's think of what we're going to do here. In order to make this easier to see also, I'm just going to draw the two triangles separately over here. Because sometimes when triangles are overlapping in any way, drawing them separately is going to make it a lot easier to see what is going on. So I just got this triangle over here, and now I'm going to get this triangle MER over here. Sorry, some of the letters got cut off a bit. I'm also just going to mark what we have so far. The green angles were here and here. But wait, I can't mark RO because RO is not a side of this triangle. If you take a look, RO extends beyond the side of the triangle. Oh, so sorry about the blurry letters. I just realized that I had the letters in the wrong spot because it was cut off. So we're just going to backtrack and remark and label the diagram. So RO is actually right here. And notice how RO is not a side of this triangle over here. RE is the full side. So RO is shorter than the full side of the triangle RE. And we also have information about HE, which is here. And notice how HE is not a side of this triangle. HO is the full side of the triangle. HO is longer than HE. So we have information that is shorter than the full sides of the triangle. When we're proving triangles congruent, we need information about the full sides being congruent to the full side of the other triangle. So this seems like a situation where we're going to have to take our smaller information and make it bigger using the addition postulate. So what we're actually going to do is we're going to take HE and we're going to add on EO right here, and that's going to make the full side HO. And HO is what we need, the full side of the triangle. We're also going to take RO, the segment that we started with, and we're also going to add on OE, which is the same segment as EO. EO, OE, same thing. And that's going to make the full segment RE, the full side of the triangle that we actually need. Now, remember to do addition, we have to be starting with two congruent segments, which we are because HE and RO are congruent from the givens. But we also have to be adding on two congruent segments. So in our proof, before we can do this addition, for it to be valid, we are going to have to state that EO is congruent to OE, and that's because of the reflexive property. It's the same segment as itself. So that's going to be in our proof to show how we get HO congruent to ER, which are the full sides of the triangle that we need. The last piece of information is going to come from our parallel lines. A lot of people don't like to mark parallel lines, but when we have parallel lines cut by a transversal, we often have angle relationships that are helpful. And here, those angle relationships are corresponding angles, which are congruent when parallel lines are cut by a transversal. Notice how they're in the same position where the parallel line meets the transversal. We have top left and top left. So one of those corresponding angles, that one is right here in this top triangle, and this one is right here in this bottom triangle. So now we see that we have the triangles are congruent by ASA. Please pause the video and try to write up the proof yourself. Make sure to get the addition into your proof, as well as the congruent corresponding angles. Feel free to pause the video so you can take a better look at the statement reason chart fully written out for this proof, because I am going to go on to the next one. Okay, for this one over here, our given information states MS is the perpendicular bisector of LP. Remember, perpendicular bisector is a two-part word. Perpendicular part means MS and LP make right angles where they intersect. The bisector part means that MS is splitting line segment LP into two congruent pieces. So LM is congruent to MP. We're also given the information from our givens that RM is congruent to QM and that angle A is congruent to angle B. So let's take a look at what we have in the two triangles. We have a side, LM and MP. We have another side, RM and QM, but that's all we have. This right angle is not the angle in the triangle. It's bigger than the angle inside the triangle. Same thing with this right angle. It's bigger than the angle inside the triangle. And the purple angles are outside of the triangles. If we want to have an angle in the triangles to use, we would need the angles that are actually inside the triangles, angle RML and angle QMP. So since we have information about the larger right angles and about the piece of the right angle, we can make it smaller to get the piece inside the triangles that we want. And that's the subtraction postulate. So let's talk about what we would be subtracting. We would be subtracting, so this right angle is angle SML. And if we take away the purple part, angle A, then we're left over with the piece inside the triangle that we want, angle RML. The other right angle is angle SMP. And if we take away the purple part, angle B, then we're left over with the side inside the triangle, the angle inside the triangle that we actually want, angle QMP. We're starting with two congruent right angles, and we're taking two congruent pieces of the right angle. A and B are congruent from the givens. And then we end up with the angles inside the triangle that we need, and then we have SAS. Feel free to pause the video to take a look at the full written up proof because I'm going to switch over to the next proof now. Okay, this will be the last one that we're going to do in this video. So in this one, we have the given information that PQ is parallel to DE. And when you have parallel lines, look out for a transversal. And here we have parallel lines cut by a transversal, and we see that letter Z. It doesn't matter if it's a forward Z or a backward Z. If you see that Z, in the corners of that Z, we have congruent alternate interior angles inside the lines on different sides of the transversal. Remember, alternate interior angles are congruent when we have parallel lines cut by a transversal. So look out for that letter Z. I recommend always highlighting the parallel lines and the transversal. We also know, and let me just backtrack here so it doesn't get confusing here. So I'm going to keep the alternate interior angles marked. There we go. So now we have those marked. And now we know that PB, so PB is from here to here. Notice how that's longer than the side of the triangle PA. So keep that in mind. It's longer than PA. And we also have AE. Notice how AE is longer than the side of the triangle BE. So keep that in mind. Once again, it's longer than the side of the triangle. If it's longer than the side of the triangle, it doesn't help us. We need congruent sides of the triangles. So we're going to have to use subtraction here to get the information just to be about the sides of the triangle PA and BE, because our information right now is too long. So let's talk about what we're going to subtract. PA subtracting AB leaves us over, I miswrote that, PB, the long segment, taking away AB leaves us over with PA, which is the side of the triangle that we need. And AE, take away AB, leaves us over with BE, which is the side of the triangle that we need. And our last given has angle D congruent to angle Q. And now we have angle, angle, side, angle, angle, side. In order for our subtraction to work, we have to be starting with two congruent segments and subtracting two congruent segments. PB and AE, our starting segments, are congruent from the givens. But we do need to state that the segments that we're subtracting are congruent as well in order for our subtraction to be valid. So in your proof, you would need to say that AB is congruent to itself, and that is by the reflexive property. Here is the full written up proof. Feel free to pause the video so you can check it out.